All right, so this is the second part of the review for Wednesday's test on the heart and the blood. So I'm going to put a few things up here that you should know. Okay, so person with a B blood type, they would have what kind of antigen?
B,
Okay, and what kind of antibody?
A.
All right, so know the blood type, and there was that great homework assignment that you had, the diagram that you had to fill out, and that's great for studying and knowing which antibodies, antigens that they're going to be producing. And we've talked about this, that you have also the Rh factor that is on here. Okay, so you should know what the Rh factor is. So it's like an additional little antigen that's added on there. So you either have it or you don't. And so if you were B, you could be B positive or you could be B negative, meaning you have the Rh factor or you don't. So taking into consideration the blood type and along with the Rh factor, who's the universal donor?
O negative.
O negative, correct. Because they can go into anybody's blood and be completely undetected because O doesn't have any antigens and they don't have the Rh factor. So who is the universal recipient?
AB.
AB
Positive.
positive. Okay. So AB positive would be the universal recipient. O negative is the universal donor. Good. How about what is erythroblastosis fatalis?
That is, that's a fetal disorder where the mother has the negative Rh factor and the fetus has the Rh positive, and the mother's body treats it like it's invasion, like a,
Rejects it.
yeah.
That's exactly right. So this, if you don't know what this is, go back in your book and read about it. But basically what Colleen said is right. If you have an Rh negative mom and dad is Rh positive and then baby is Rh positive. So in the first birth is when you'll first get the first mixing of the blood. So during the first pregnancy, the mom doesn't have to worry about it so much. But once she has that baby, then they'll get the mixture of bloods, and then mom will develop the antibodies against the Rh factor. So if she has another baby that's Rh positive, and then mom's antibodies will be like, whoa, what's this invader here? And it'll go and it will. Okay, it'll agglutinate the RBCs, meaning it'll clump them up. Okay, and that's obviously not good in a person's bloodstream. So go back and look at that and read through that. Okay. Um, what does hematopoiesis mean?
It's the formation of blood cells
Mhm. And where does it occur?
in the bones.
In the bone marrow.
Yes.
Excellent. Okay. Should know the different types of anemia. Make sure. There is anemia in here. So types of anemias, you're going to have aplastic. And in our game, Kahoot game, how did I say that I remember the aplastic?
Because plastic is a, go ahead.
Go
A
ahead.
toxin. It's a toxin.
Mm-hmm.
It's toxic, yes.
Okay. So being exposed to toxic chemicals, and so it can cause destruction of bone marrow. Okay. And hemorrhagic. If someone is hemorrhaging, what's happening to them?
They're bleeding out.
Okay, so extreme blood loss. So if you have a lot of blood leaving the body, obviously you're going to lose a lot of red blood cells in the process as well. So that is a type of anemia because due to blood loss. Hemolytic. Lysis is to destroy or explode. And so this literally means like destruction of the blood. So caused by RBC destruction. Okay, hemolytic. Now, there are a couple different types of hemolytic anemias that they talk about in your book. So a couple examples of these would be sickle cell and thalassemia. What is sickle cell anemia?
Sickle cell is when your red blood cells are not shaped properly. They're not shaped like the concave biconcave disc. They're shaped like a sickle,
Yep.
and they're it's usually a disorder associated with African American ancestry.
Mhm. And so what'll happen is it's harder for them to move through the bloodstream, and you can get clotting on there as well because they're not moving through as effectively as they should. Now, how about thalassemia? So
If nobody else knows, I will take that one. That's if you have Mediterranean ancestry.
What happens to the hemoglobin?
You can't produce it, it's a defect.
Yep. So you can have low amounts of hemoglobin and also have some abnormally shaped cells in there as well. Okay. And pernicious anemia. This is oh gosh. B12 deficiency. There's a couple other ones in here as well. Folate deficiency, similar to pernicious. There's iron deficiency anemia as well. So those are a category under the deficiency anemias. So I should have actually put that. An example would be pernicious. Okay, so we have aplastic, hemorrhagic, hemolytic, and I gave a couple examples, and deficiency anemia, and an example would be pernicious.
Hemoglobin.
Yeah, so when we just talked about those deficiency anemias, and we said pernicious is a deficiency in B12, and then we have folate is another one that we can be deficient in, and iron deficiency. So if we're deficient in those, we're not going to be able to properly make hemoglobin. And if you remember, we need hemoglobin in order to carry the oxygen to the different parts of the body. So hemoglobin is a protein. It's actually two pieces of protein. We have the heme and we have the globin, and they bind together, and they actually have oxygen capacity to them. And so if there's something wrong with the hemoglobin, they're not going to be able to have all the oxygen bind to it, and you're going to have problems with that. So we need these three things in order to make the hemoglobin, again, which helps us to carry oxygen.
Isn't
How
it
much
4 to 6 liters?
8%.
Oops, not 4d6, 4 to
4 to 6, yes.
Liters.
4 to
Liters.
6. Yep. Okay. And in the blood, how many RBCs do we have?
You want the percentage? Is that what you're asking?
Nope, we're asking like per cubic millimeter of blood.
Oh, Jesus.
Isn't it like 5 million or
Yeah.
something?
Yep.
Yeah, yeah,
I was like,
it's a
wait a minute.
lot.
So the cubic millimeter is mm, and then a super score 3, like the little 3 above it.
Yeah.
And so when we did our lecture the other day, when I drew out the, the tube of blood, and we talked about the different layers and stuff, and we said that we have 5 million red
Million.
cells per cubic millimeter. And how many white blood cells?
5 to 10,000.
Depending on what book you look at, like I learned it as 5 to 10. I think your book actually says your book says, no, it does say 5 to 10 in here as well. Okay. Okay, so we have 5 to 10. So in order, like if someone was having an infection, they would have greater than 5 to 10,000 white blood cells. Okay, so as long as you're within 5 to 10, you're good. All right, you're not in an infection situation. And how many types of white blood cells do we have?
5.
5.
Who can name them?
So you have the Bens, basal, eosinophil, neutrophil, and then you have macrophage. No,
Nope.
neutrophil. And you have
It's the
Lymphos-
granular.
lymphocyte, and then you have what's monocyte.
Monocytes.
Monocytes.
Close.
Okay.
I knew there was another one.
Now, what is a macrophage though? I mean, because they can be, like we know that neutrophils are what's called
Phagocyte.
phagocytes. Okay, that means that they're going to eat bacteria. So a macrophage is just a very large eating cell.
Right.
What's a thrombocyte?
So it's a clotting cell.
Mm-hmm. And what is our clotting? What are our clotting cells called?
Platelets.
Mm-hmm.
They're baby platelets.
Platelets. What is a
Red blood cell.
Mhm.
White blood cell.
Okay. Okay, for this next part, let's go through, if we were a red blood cell and we wanted to track our circulation, okay, through the body, we'd have a certain step-by-step process. Let's go through that process.
Like top to bottom, like
So,
from Vita.
yep, so we're gonna start with this red blood cell has been down in my big toe and it deposited all of the white blood or the oxygen to my big toe and it picked up the carbon dioxide and it's heading back up to the heart and it's gonna be heading back up to the heart through the
Inferior vena cava.
yeah, so we have the inferior and superior vena cava, so depending on where it's coming from. Okay, so blood comes back to the heart through either the inferior or the superior vena cava. And which chamber does it go into?
The right atrium.
Mhm. Okay, from the right atrium, it's going to get pumped down and it's going to go through a valve.
Tricuspid.
Okay, and now it's going to go to the bottom chamber, which will be the,
Right ventricle.
okay. And now think about this. So the blood is now down in the right ventricle, and that tricuspid valve had to snap shut so that the blood does not go back up into the right atrium, right?
Pulmonary semilunar valve.
Hold on. Yeah, that'll be the next thing. But so just remember that each valve protects the blood from going back to the one that it was just in. So the tricuspid valve is going to prevent blood from the right ventricle from going back up into the right atrium. And then, like Jen said, now the blood is going to be pumped from the right ventricle. It's going to go through another valve, and this will be the pulmonary semilunar valve. And it's now going to go towards the lungs, and what is going to bring it to the lungs?
A pulmonary artery.
Pulmonary artery, and remember this artery will be blue because the blood has not gotten the oxygen yet. Now again, remember that pulmonary SL valve is there to prevent blood after it goes into the pulmonary artery. That semilunar valve is going to snap shut and is going to prevent blood from going back into the right ventricle.
Unless you have an incompetent valve, right?
Exactly. So the incompetent valve isn't doing its job and it'll prevent some backflow. Okay, so now pulmonary artery brings the blood to the lungs, and what's happening at the lungs.
Exchanging.
Getting oxygen.
Yep, dropping off that carbon dioxide. So that's what we breathe out, and we took a big breath of air, and that oxygen is going to be going onto those red blood cells. Okay, now the blood is going back to the lungs, and it's going through the,
Pulmonary vein.
now our blood is red. Pulmonary vein is going to bring it back to the heart. And which chamber is it going to go into?
Left atrium.
Okay, it's going to be pumped down, and it's going to go through a valve.
Bicuspid.
Mitral.
Yep, either the mitral or bicuspid valve, whichever word that you see there, can be interchangeable. And now it's going to go to the left ventricle. Okay, now which valve does it go through?
Semilunar.
Which one?
Isn't it the semilunar? No, aortic semi. That. I meant that. Semilunar, however.
Okay, aortic semilunar valve. And now
Aorta.
the aorta, the largest artery. Okay, now it starts branching down. So we're going to have
Arteries.
arteries,
Arterioles, wherever how you say it.
arterioles.
Okay. Then capillaries? No.
Yes.
Mhm. Okay, we're going to have the exchange here. Second place where you have exchange. Okay. All right.
And
Now-
is it venule? No,
Mhm.
not vessels. Is it venules? Oh, it is.
So now the capillaries are the smallest blood vessel, okay? So now we're gonna get one step bigger, and now our blood is turned back to being blue because we've now dumped off all the oxygen, picked up the carbon dioxide, now it's heading back towards the heart. So we have the venules, and then we're gonna have,
Veins.
and then the vena cava, which is the largest vein. And then that's gonna go back to the heart and start over again.
Yay!
Okay, good job. So if you were to have a question that said something like, which valve would prevent the blood from flowing back into the left ventricle? What would you answer? Which valve is preventing blood from flowing back?
Aorta, the aortic semilunar valve.
Correct, because yes, the left ventricle is what's pumping the blood into the aorta, and the valve that's between those two is the aortic semilunar valve, okay? So you really have to think about and know your step-by-step process when you're gonna do this test, because it's gonna ask you questions like that. It's not gonna ask you just to write out all of these. You have to think about it and know, like if it said something like, which chamber would the blood be entering after going through the mitral valve? If it said after the blood has passed through the mitral valve, which chamber is it going to?
Left ventricle.
Left ventricle, okay? So understand the process and not just memorize the process, okay?
Mm-hmm.
So there's a lot of them that are like, which chamber would it be after it does this? Which valve is gonna prevent the blood from backflowing into here? So that's why I was kind of going through some of that with you, so you understand each section. Now, which of the chambers are the receiving chambers?
Atrium.
Right.
both the right and left atrium. So the
Yep.
atrium are the receiving chambers, and which ones are the discharging?
Ventricles,
Those.
right? Your left and right ventricles, you're discharging.
Yes, yep. Okay. We have not talked a lot about the conduction system on our reviews. I'm assuming that Becky has done lecture over the conduction system.
Oh.
So what's kind of the process for the conduction system of the heart? What triggers it? What is called the pacemaker of the heart?
Your SA,
Mhm.
node,
SA, and this is also called the,
pacemaker, or whatever. Sinoatrial. Sinoatrial. I never say it right.
sinoatrial. So that starts the process. And then it sends that stimulation across the atrium. And then it sends that signal to the next thing, which would be the,
AV node.
and this is called the,
Atrial ventricular, something like
okay? So there's a little bit of a delay between the SA node and the AV node, because if you have the SA and the AV stimulating their parts at the same time, our heart would all contract at one time. We can't have all four chambers contracting at the same time. So the SA node sends the impulse across the atrium, and there's a split-second delay for it to get to the AV, so that the atrium can contract and send the blood down to the ventricles. And now the ventricles are being stimulated. So it's going to go down the center of the heart first, okay, down in the ventricles, the center of the ventricles. What are those bundles called?
His?
Hmm? Bundles of His. It's not his, it's his. Okay, so they're going to go down from the AV node. The stimulation is going to go down the center of the heart, and now it's going to branch out to the right and the left side. What are those fibers called that are on the outer edges of the heart?
Peduncle, or they also call it,
Purkinje.
whatever. But isn't it also subencardial branches or something too? That's the other name for it.
I think there's different parts to the Purkinje fibers of what you're talking about, but in general, they're just called the Purkinje fibers.
Purkinje, because the subencardial branches or something.
Yeah, I think it's when they, yeah, I'd have to go back and look at it, because I know that there's parts when they start breaking apart into different sections.
Maybe that's what I'm thinking.
Yeah.
Okay. I know there's something else with it. Okay.
In general, you just need to know the Purkinje fibers.
Purkinje.
Kim, do both atrium contract at the same time and both ventricles contract at the same time? Okay.
Yep. So when we talk about the flow of blood, we're talking about the flow of blood in just so that we can, demonstrate if we were traveling with one red blood cell. But yes, you have to remember that these are not happening where it's the right atrium, right ventricle, and then it comes back, left atrium, left ventricle, and only one chamber is happening at any one time. These are happening simultaneously. So both atrium are going to fill with blood. The vena cava is going to bring the deoxygenated, and the pulmonary vein is going to give the oxygenated blood, and they're going to fill up the atrium. Okay, then they're going to get stimulated through the AV node, and they're going to contract at the same time, and the blood is going to go down to the ventricles. Now the ventricles are getting stimulated, and both ventricles are going to contract, and they're going to pump the blood out. And at the time that the ventricles are pumping the blood out is when the atrium are refilling again. And so now the ventricles are empty, the atrium are full. They pump the blood down to the ventricles. Okay, ventricles are full, atrium is empty. The ventricles pump the blood out as the atrium are filling again. And this happens over and over and over. And the lub-dub sound that you're hearing when the heart goes lub-dub, 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 that's the chamber, or the valves that are closing. So when they snap shut, that's what you're hearing. So when the bicuspid and the tricuspid valves snap shut together, that's your lub. I believe I'm saying that right. And then when the semilunar valves close together, that's your dub. So it's lub dub, lub dub, lub dub. And that's the vent or the valves closing, and that makes that sound, the heart sounds. So if someone has a heart murmur and those valves aren't closing all the way, you hear more of a swishing than a actual snapping. Okay. And okay. All right. What did I just draw there?
Cricket line.
The normal heartbeat,
It's the heartbeat.
the EKG reading.
Yeah.
So this would be an electrocardiogram
Yeah.
measuring the electrical activity of the heart.
Mhm.
And so our heart has to have the electrical impulses in order for it to beat. And so the first one that we look at here, okay, so this first line right here, where it's not, doing anything, this is where the heart wall is completely relaxed and no change in electrical activity. Okay, so that's kind of its little resting phase. Now, if we're looking at this part right here, what is this first little blip called?
The
P
P
wave.
wave.
P-wave.
P wave.
P, okay? So this is our P wave. Now what's happening here is we are having the atrial walls
Depolarized.
depolarize, okay? Trying to think how I've told my students to remember the difference between depolarize and repolarize. Yeah, can't think of anything right off the top
It's
of my head.
like flipping a switch, like turning the light on and turning it off,
Yeah.
sort of.
Yes, I know there was something I had in my head before, and I don't want to take too long to think about it because we're recording here. But anyway, so this is depolarizing of the atrium. Okay, so this is when they're starting to get all of those cells of the atrium to be depolarized, okay, and all the electrical activity is moving across. I think someone's typing on their tablet. Okay, now the next one is the
QRS.
QRS. And what's happening at the QRS?
That's the ventricle.
Depolarized of the ventricle.
So the QRS complex occurs as the atria repolarize, meaning they're getting rid of their electrical activity, and the ventricle walls are depolarizing. And now at the end of that, the atrial walls are now completely repolarized and the ventricle walls are completely depolarized, and now is when you have the contraction. So the first one is the depolarization, the P is the depolarization of the atria, and you get the atria contracting. And then the second one, the QRS, is the depolarization of the ventricles, and then you get the ventricles contracting. And that's why the ventricles are so much bigger than the atria, which is why you have such a big QRS complex compared to the P wave. And then the last one here is the
T-wave.
Okay. And in the T wave, it appears on the EKG when the ventricular walls repolarize. And then once the ventricles are completely repolarized, we are back to the baseline and essentially back to where we started again. So there's contraction that we have, and then we have contraction and relaxation. So what did we say? Which one, systolic, diastolic, or systole or diastole, is the one when the heart is actually contracting?
It's
Systole.
systole.
Okay. So on our blood pressure, we'll say like 120, and so we would say like 120 over 80 would be kind of a normal blood pressure. The 120 goes on top, and that's the systolic pressure. 80 goes on the bottom, diastolic. So both of them are important, but we really look at the bottom number because we want to make sure that our heart is able to relax. And so we look at that bottom number, and if the bottom number is really high, that means that the heart isn't able to relax in between each contraction, and that's not a good thing for our heart. Both numbers are important, but we want to make sure that our heart is relaxing in between contractions. Okay. All right. So that's systolic, diastolic. And I'm going to put a bunch of terms up here, and I want to make sure that you guys, if you don't know these, look them up so that you understand what they are. I'm not going to go through each one of these. I'm just going to put a list up here. These will be disorders that you need to be familiar with and know for the test. I'm going to erase these and start at the top again. Or actually, I can start a new text box.
And that was this heart valve dysrhythmia.
Hey, Kim, is that the same thing as CHF that you put over there? Congestive heart failure.
Oh, yeah, sorry. I put it up.
No, you're fine. I just wanted to make sure.
Yep, good call. All right. Okay. And I'm going to stop recording right now.